Good morning. So we have discussed in our previous module what are fuels, types of fuels, and we have discussed most of the things about the fossil fuels itself. Petrol, diesel, kerosene, how petrol, diesel, kerosene determine the calorific value of petrol, diesel, kerosene. And from there we slowly move towards the renewable sources of energy, alternate fuels, biodiesel, fuel cells, and later we move to the alternate, renewable source of energy, that is solar energy. So other than fuel cells and what are the other alternate sources for fossil fuels? We have batteries, right? So what are batteries? How batteries have done? So we're going to discuss what are batteries, different types of battery, and we're going to take few examples of primary or secondary batteries, and let's discuss the construction and working and applications of these batteries. So first of all, what are batteries? So batteries are made up of two or more galvanic cells. So battery, when two or more galvanic cells, when they are connected either in series or parallel to not to get a necessary current, then it is called as a battery. When two or more galvanic cells, if they are connected either in series or parallel, it forms a battery. So batteries are classified into three types. Primary battery, we have a primary battery over here, secondary battery, and a reserve battery. So what are primary batteries? All non-rechargeable batteries, all use and throw batteries come under this category, primary batteries. All single-use batteries, use and throw batteries, non-rechargeable batteries will come under this category. So this here the electrical energy is obtained with the expense of chemical energy. So here the electrical energy is obtained with the expense of chemical energy. That is a primary battery or secondary battery or reserve battery. So in all case of batteries, so energy is obtained with the expense of chemical energy. So in primary batteries, so the shelf life is also more. So we can withdraw the current as long as chemical energy is present. So in primary batteries, the reaction is irreversible. So whatever reaction occurs, it is irreversible. So all cell reactions are irreversible. So examples for primary batteries are zinc manganese oxide battery, zinc air batteries, etc. So where is the zinc air battery used? So zinc air battery is used in hearing aids. So you can see hearing aids, right? So the deaf people where they use. So there zinc is anode and the cathodic active species. So active species is the reactant. So the cathodic active species is oxygen. So oxygen is available everywhere, right? So when the air enters, that will act as the active species. So the zinc air battery, it will be very small, tiny, minute. So it can be fixed in that hearing aid. Okay, so zinc air battery, so zinc will act as anode, oxygen will act as the cathodic active species. So zinc manganese oxide battery, zinc air battery, we have n number of primary batteries. So all the batteries which are used in your calculators, the batteries which are used in your wall clocks, the batteries which are used in your watches, so all these are examples for your primary batteries. Then let us see what are secondary batteries. So all rechargeable batteries are called as secondary batteries. So here the cell reactions are reversible. So cell reactions, what are the cell reactions occurring here? So the cell reactions, cell reactions is reversible. So what are the cell reactions at anode? What happens? For example, let us consider lithium ion battery. So when you're using the battery, what happens? When you're using the battery, lithium undergoes oxidation. So lithium undergoes oxidation to give you lithium plus an electron. So this electron will be used for working your apps or anything. So lithium ion battery is usually used in lithium ion batteries are used in mobiles. When you're using battery, it requires current, right? So the lithium ion battery stores the electrical energy in the form of chemical energy. So lithium undergoes oxidation to give you lithium plus ions and electrons. The electrons are used in order to function the battery, whereas apps during calling or Facebook, WhatsApp, anything. Okay, so that this process is called as discharge process. So once the battery percentage comes down to 10% or 15%, you're going to put the battery for charging, isn't it? When you put the battery for charging, you're supplying the electrons from external power source. We're supplying electrons from external power source. We're connecting it to the plug point or socket, right? So we're giving the electrons. What will happen? Lithium plus accept the electrons and gets reduced to Li. Okay, this is the reaction is reversible. So this process is called as what? Discharge, whereas the reverse reaction is called as recharge. So forward reaction is called as discharge, backward reaction is called as recharge. So here in almost all secondary batteries, all rechargeable batteries, the reactions are reversible. That is, the battery, and during the forward reaction the battery acts as a galvanic cell. During the backward reaction the battery will act as a electrolytic cell. So the battery is having the capability of acting both as galvanic cell as well as electrolytic cell. So forward reaction, when you're using the battery, it will act as a galvanic cell. When you're charging the battery, it will act as a electrolytic cell. So these batteries can be recharged by passing electric current, as you know very well. So the secondary batteries, the examples for secondary batteries are your lead acid battery, lithium ion battery, etc. Right. So lead acid batteries are used in almost all automobiles in order to give the spark in your engine. So in order for your engine to start, right, you require power. For your lights, headlights, so for various things requires power. Your four-wheeler, your car, that is a six-wheeler, so all the batteries function using your lead acid battery. So next type is your reserve battery. So here a key component is separated from rest of the battery. Usually electrolyte is a key component. So when if you have it is like a key, lock and key mechanism. Here anode and cathode will be present here, electrolyte. So when you connect this, so what will happen? It will become a complete cell and electrons will move from anode to cathode. So when you disconnect this, what will happen? It is a dead, nothing. So electrolyte is not there, so ions will not move. So anode is cathode is present over here, electrolyte will be present over here. When you connect it, it forms a cell and it will function, we can withdraw the current. When you disconnect, what will happen? It is simply a waste part, so we cannot. So this type of cells, example for this is zinc silver oxide, magnesium silver chloride batteries, and these are mainly used in military applications. Okay, so let us see what are the differences between primary and secondary batteries. So in primary batteries, they are non-rechargeable, whereas secondary batteries, they are rechargeable. So primary batteries are non-rechargeable or reused, whereas secondary batteries, they can be rechargeable and they are reused. So as per the cell reactions, the primary batteries, the reactions are irreversible. In secondary batteries, the reactions are reversible. We have seen that, okay, right? So can be used only once. Primary batteries, use and throw batteries. Your batteries used in your clocks, watches, calculators. So whereas your secondary batteries, it can be used more than once. The batteries used in your cameras, white torches, etc. So used in portable devices, as they produce more current immediately, so needs to be charged before they used. So here the self discharge is more, whereas self discharge is less in case of secondary batteries. So example for your primary batteries, you have zinc carbon battery, which is used in flashlights, toys, right? Heavy duty zinc chloride battery used in radios. We have alkaline battery used in all both. Lithium batteries used in cameras. Silver mercury oxide battery used in hearing aids, watches, calculator. You have a zinc air battery used in the hearing aids. That is for deaf people. A small device to be used for deaf people. Hearing aid is nothing but people who cannot hear. When give the device, right, with the help of that they can hear. That is called as hearing aid. So some of the example for your secondary batteries: nickel cadmium battery, nickel metal hydride battery, lead acid battery, lithium ion battery. So nickel cadmium battery. So before your we got lithium ion battery, the nickel batteries were used in the laptops. So all the laptops were depending upon your nickel batteries. So once the lithium batteries were invented, so now each and everything is depending only upon lithium batteries. So your cameras, for that matter, we use lithium batteries. Toys, we use lithium batteries. Portable devices, any device, we use lithium batteries. Your portable machines, gardening machines, your power tools, drilling machines, everything use your lithium batteries. We are no more depending upon the nickel metal hydride battery. Okay, so lead acid battery, as I told you, it is used in almost all automobiles, maybe buses or four-wheelers or lorries, right? It is used in the almost all vehicles, or for the case of power, as well as to ignite for the sake of ignition. Okay, so reserve batteries. As I told you, one of the cell component, usually the electrolyte is kept isolated and whenever required it is attached. So example, magnesium mercury chloride, magnesium silver chloride. It is mainly used in military applications. There is a small animated video. Just watch how
Step
a
move around it.
battery
Here's how it works. With the
functions.
circuit off, electrons in material A are stuck in their high energy, high stress atoms. Out of reach and on the other side of this electron barrier are material B atoms, which would offer an easy, cushy, low energy level position. Let's turn the circuit on. Now you've offered electrons a path to happiness. Since they can't go any other way, they begin flowing through the circuit to material B. Back at material A, the atoms are losing electrons, because that's where the electrons are coming from, and they begin turning into positively charged ions. As we mentioned before, ions always want to be neutral, so these guys need to find a negative charge, so they go to where the negative charges are, in material B, where all the electrons are going. You'd think that these ions would just meet up with their lost electrons and become neutral atoms again. But unfortunately, the electrons are way happier where they are now, so the ions have no choice but to kind of mingle with the atoms of material B. So what we've got is kind of a mishmash with B atoms mingled with A ions. As the battery discharges, electrons and ions are making their way from A to B. When you can't fit any more material A ions into material B, the battery is fully discharged. To recharge the battery, you just do things in reverse. Instead of a circuit, you're putting an energy that forces the electrons back into material
now the battery acts as a
the ions then leave
cell.
material B and rejoin their lost electrons, and the battery is ready to discharge again.
Thank you.